Hello there, Wildcats. Welcome back to your geometry class. Today we're going to be discussing about law of sines and law of cosine. Okay, so our objective in in this one video, we have two topics. First is we're going to understand why the law of sines applies to any triangle. And then second is we have to use the law of sines to solve problems. Under law of cosine, our target or our objectives are we develop an understanding of the law of cosines, and we have to use law of cosines to solve problem. All right, so um, our essential understanding for law of sines that how can the law of sines be used to determine side length and angle measures in acute and obtuse triangle. So we did trig ratios. We did trigonometric ratio because we have a right triangle. Now the question there is, what if the triangle is not a right triangle? So here comes your law of sines and law of cosine. All right, so let's start with our first example. We immediately jump into we explore the ratio, your sine ratio. How can you use sine ratio to relate the length and angle measure in triangle ABC? First is we are going to construct an altitude from vertex A. So what I'm going to do here is I'm going to draw a vertex, or from vertex A, I'm going to draw an altitude. So from A, and then you draw a there, the altitude. Let's say this is D. Okay, from A to D. So that's D, guys, not B. So from A to D. Right. Sorry about my handwriting there. So we construct the altitude AD from vertex A. Now, the altitude intersect BC at a point D, forming right triangles. So we have triangle. So you have now two triangles here. We have the first one, we have triangle ADB, ADB, and also we have triangle ADC, right? ADC. Okay, so we are going to write an equation. We are going to write an equations for sine B and sine C using the right triangles. Just a simple tip, guys. Recall the sine ratio relate the length of the opposite side to the length of the hypotenuse. So our equations are, we have sine B. So we have sine B is equal to h over c. So sine B is h. So this is your h. This is the height of the altitudes. H over c because it's opposite over hypotenuse. And let's play with that. And to find the value of h, this will become h is equal to c, multiply that by your c, multiply that by sine b, multiply that by sine b. It's messing up my pen. So we have c, so c, multiply that by, sorry about that, guys, my pen is messing up. So we have c, multiply that by sine b. All right, so the value of h now is equal to sine b times c. And we also have to get your sine c. your angle C. So we have sine C is equal to opposite, which is H over B. Okay, to find the value of H, we have to multiply B times sine C. So B is equal to, I have to make sure that it's readable. So B times, okay, B times sine C. All right, so we solve for, we are done solving each equation for H. Now we have to set the two expression for H equal to each other. So H is equal to H, or we can now say that we have C, this one, C times, I'll just use a dot here, sine B is equal to B times sine C. So we are going to this must be capital letter B. So we are going to divide this both by B and C. So we will now have a ratio of okay, sine B over B is now equal to sine C over C. So the definition of sine ratio only includes acute angles for triangles with right and obtuse angles. You can extend the definition of sine and cosine to include these angles. Now, let's see the concept of your law of sine that I have wrote there. So for any triangle ABC with the side length A, B, and C, opposite angles A, B, and C respectively, the law of sines relates the sine of each angle to the length of the opposite side. So we have sine A for the angle A over A, the side A, is equal to sine B, angle B, over side B is equal to sine C, okay, the angle C, over the measurement of your side C, right? Maybe we can apply that with an example. Okay, using law of sine, find the side length. For triangle XYZ, what is YZ to the nearest tens? Okay, so the measurement of XY is 7, the measurement of angle X is 51, and then the measurement of angle Z is 77. So we have to identify pairs of known side and angles. So the measurement of angle Z and the length of its opposite side, which is XY, are known. Okay, and the measurement of angle C is angle Z, or angle X, is 51, which is, we know it already, it's given there. And then the length of YZ, which is unknown, okay, we're going to use that. So use the law of sine to write and solve an equation for YZ. One of the common error of some students, you have to be careful to correctly write the ratio of sine of an angle and its opposite side length. It may be helpful to draw an arrow for each angle that points to its opposite side. So take a look at your, if you look into 77 here, angle 77, that's angle Z, the opposite side is 7, and then opposite side of 51 would be your YZ. Now, we need a calculator in this activity, okay? So I'll pull out my calculator. Now, I'm now going to set my equation here. We have to use the law of sine to write and solve the equation for YZ. So because the unknown is YZ here, so yz is unknown. So yz is unknown there. So sine 77 degrees. Okay, sine 77 degrees. Opposite of 77 is 7. Okay, so I'll put there over 7 is equal now to sine 51 over the known yz. Okay, and then you cross multiply, and then it will give you, if I'm going to cross multiply that in the same way, when we are solving trig ratios, it would give me yz times sine 77 is equal to 7 times sine 51. Okay, and of course I'm going to divide everything by sine 77. Why? So that your yz will be isolated. Of course, this will be cancelled. So the measurement of yz is equal now to 7 times sine 51 over sine 77. So using our calculator, we can put that there. So the measurement of yz is equal to, I'm going to pull out my calculator. There, you can see my calculator there. So I'll just get my calculator here, turn it on, and then make sure that it's in degree form. And I got alpha y equals to make it to have a fraction there, and press 1. So I have a fraction. So close parenthesis 7, and then another close and open parenthesis sine 51. And then I'm going to close that twice, and then I'll go down, and I have sine 77. And then my answer would be approximately 5.58 or 5.6. So the measurement of yz, okay, the measurement of yz is 5.6. So it's 5.6. Okay, next example. In our next example, we are going to use law of sines to find the measurement of an angle. Now, in here, missing angle. So we are looking at a missing angle here. So first is we have to use the law of sine to write and solve an equation to find sine s. Okay, so we're looking at the measurement of sine s. And then, let's see, I have sine s over RT, that's the opposite, is equal to sine t over the opposite is RS. So just plug in. We have sine S, which is unknown. Sine S over RT is 12.7. RT is 12.7 is equal now to sine 74. Sine 74 over RS, which is 12.3 feet. And then you cross multiply. You cross multiply, it will give you sine S is equal to 12.7. 12.7 multiply that by sine 74, and then divide this one by 12.3. Okay, so we have to use our calculator. All right, so your sine S, because we are looking at angle S, so sine S is equal to, this is approximately 0.9925. but we still have to double check that using our calculator, guys. Okay, pull out my calculator there. So I have sine S second, and then we have that one, and then we have 12.7 multiply this one by sine 74. I'll double close that. There you go. And then I have 12.3. So that is 9925. All right, so still we are looking, because we are looking at the angle. So what I'm going to do here is I'm going to get the inverse, just like what we did in our trig ratio before. So use the inverse function of the sine to find your missing angle S, or yeah, the measurement of S. So the measurement of angle S, okay, because we have that. So S now, S is equal to, or the measurement of angle S is equal to sine raised to negative 1 times 0.9925. Okay, let's do that in our calculator. So I'll do second function sine, and that's 0.9925. So the measurement of angle S would be 83 degrees, or 82.9, so 83 degrees. So the measurement of angle S is 83 degrees, while the measurement of angle R, okay, the measurement of angle R now, measurement of angle R, because this is 83, therefore this triangle composed of 180 degrees. So angle R would be 180 minus 74 minus 83. So that's approximately angle R would be 23 degrees. There you go. Okay. Next is we have apply the law of sine here. So the map shows the path of pilot flew between Omaha and Chicago in order to avoid a thunderstorm. How much longer is this route, that the direct route to Chicago? Step one is use law of sine. So it will have sine sine 113 degrees over 471 is equal to sine 22 over x. Okay, you cross multiply that, so you have x is equal to 471 times sine 22 degrees over sine 113. So you go and look at your calculator and put that there. It will give me again alpha y equals, enter that there, as a fraction 1, and then I'll put there 471, and then parenthesis sine 22. I'll double close that, and I'll go down sine 113, sine 113, then close it, and then enter. It would give me 191.7, so 191.7. So my x here would be 191.7, and we use a minus, maybe, yeah, it's miles. All right, so this is the value of x. Now let y represent the distance from Chicago to the turning point, find y. So to determine that, So we have 180 degrees minus 113 degrees minus 22 degrees. That would give us 45 degrees. Thus, the use of low sine would be sine 113 over 471 is equal to sine 45 degrees over y. So cross multiply, put this in your calculator, 471 times sine 45 degrees over sine 113. Sine 113. So our y is approximately 361.8. So you put that again in your calculator. So your step 3 is to find the total distance the pilot flew. So 191.7 plus 361.8 miles would give you 553.5 miles. So the pilot flew 553.5 miles minus 471 miles. So it's 82.5 further. Okay, it's farther because of the thunderstorm. All right. Now let's proceed with the law of cosine. Your law of cosine, let's jump into the conceptual understanding. Let's jump into the concept. For any triangle ABC, and the law of cosine relates to the cosine, each angle of the side length of the triangle. So we have all of these equations that is mentioned there, and also the concept video I posted here in your module under this module. So I want you to watch that. So let's jump into our first example. We're going to use the law of cosine to find a side length. So what is the measurement of BC to the nearest tenth? Right. So we are going to apply the law of cosine. So the side length opposite angle A is unknown. You know two side length and the measurement of their included angle A. So use the law of cosine to write and solve an equation for BC. So I would put there BC squared is equal to AB squared plus AC minus 2AB times AC times cosine A. All right, so BC squared, okay, BC squared is approximately, we have AB squared, it's 8 squared, plus AC, that's 10 squared, minus 2, the measurement of AB is 8, the measurement of AC is 10, and then cosine 57. Okay, so actually we can go and directly put this one in your calculator. So I got there 8 squared, 8, sorry, 8, I'll just clear that out, 8 squared, okay, plus 10 squared, 10 squared, and then we have minus 2 times 8 times 10, okay, and then times cosine 57. Double close that. So the answer is approximately, that is 76.864, or yeah, so 76 Sorry, I didn't get that. 76.86. So 86. 70, not 74, 76.86. 76.86. And then you still have to extract the square root of this one. So BC is approximately, that is 8.8. Okay, so BC is 8.8. This one, it's 8.8 unit. All right, now we're going to use law of cosine to find angle measure. So the optimal tilt for Kiana's solar panel is between 58 degrees and 60 degrees. To the horizontal, has Kiana's placed his solar panel at an optical angle. All right, so first is we're looking at QR, which is 19, and then of course the missing angle is angle P. Okay, we're looking at this one, the angle here. So we have QR squared is equal to PR squared plus PQ squared minus 2 PQ and then QR times cosine P. So that's cosine P. So just plug in. So we have 19 squared is equal to PR is 18 squared, and then PQ is 20 squared minus 2 times 18 times 20. And then we are missing the cosine P. And then we are missing cosine P. Sorry about that. That's cosine P. And then just do the process there. We will be having, of course, you transfer that cosine P here. So we have cosine P now is equal to negative 363 over negative 720. This, okay, so cosine P is equal to positive 0.5042. Now, of course, we transfer this one so that we will have P, the measurement of angle P is equal now to arc cosine times 0.5042. Okay, so if you go and look at your calculator right now, we'll have arc cosine 0.5042 will give us the measurement of P, which is 59.72. So the measurement of angle P is 59.72 degrees. Okay, there you go, guys. So that is all about your law of cosine. Now your work, because this video is a discussion video, so I want you to pause this video and I want you to answer this this question, and I want you to pause your answer, complete work in our discussion discussion board, and you just comment your answer in this discussion. All right, thank you guys, and we'll see you next time. And I invite you to join us in our live Zoom meeting. Bye, guys.